In this problem, you're asked to graph an absolute value function and state how it's obtained from its parent graph. So that's the hint that we are expected to graph this function using transformations. So the parent function here, oops. Okay, here we go. The parent function here is just the basic function from your library of functions, in this case the absolute value of x. Without the negative in front, or the -2, or the +3, strip away all that extra stuff, and just look at the basic function. So in this case, like I said, absolute value of x. It would be a good idea to go ahead and get that graph on your paper. So it's nice if you remember that that's that V shape. Looks like this. But if we're going to apply transformations, then we need to plot at least a few points precisely. So maybe you remember that V has its corner here at the origin at 0, 0. And from there, it just goes up 1 over 1. Because the absolute value of 1 is 1, absolute value of 2 is 2, absolute value of 3 is 3, and so on. And I'm going to make this a dotted graph because it's certainly not our final answer here. Absolute value of -1 is 1, absolute value of -2 is 2, just to plot a few points. Absolute value of -3 is 3. So we get this side of the V there. Okay, so this is the graph of just plain old y equals the absolute value of x. Now we need to think about transformations. So the given function, I'm going to write down here, so I can write some information right next to it, is negative absolute value of x minus 2 plus 3. So there's 3 elements that are added to the function here. First, that negative out front. So if you have a -1 times the function, so a -1 outside of the function, that's going to be a vertical reflection. That's the way I look at it. Anything outside the function is a vertical change in the graph. So in this case, it's going to flip it upside down, or, for being more precise here, reflect over the x-axis. Now the -2, we're subtracting a number inside of the absolute value, inside of the function. So that's going to result in a horizontal change in the graph. And when we subtract a number, that shifts the graph right 2 units. Finally, there's this +3 added outside of the function. So if it's outside, it's a vertical change in the graph. And +3 shifts the graph up 3 units. Now we also need to be careful with the order that we perform these transformations in. Horizontal shifts to the right or to the left should always be performed first. And vertical shifts up or down, so in this case the up 3 units, should always be performed last. So this is going to be number 3 out of our 3 transformations. We should do that last. And so reflections and stretches, those you should do in the middle. So there I've numbered the order that we should perform those transformations in. All right, and now you should pick, at a bare minimum, 3 points on this graph. Even better would be more like 5 points to transform one by one. I'll probably talk about 3 of them in this video, and it'll probably give you a general idea. So if you take the point, let me take this point at -1, 1 right here, and perform the transformations. So if I take this point and number 1, shift it right 2 units. So I've shifted it to here. Now reflect it across the x-axis. So right now the y value is +1. It's going to reflect down to -1. So again, sketching what I've done so far, I've taken this point, shifted it right 2, reflect it over the x-axis, reflect it vertically across the x-axis, and then shift it up 3 from there. Let me draw a few arrows to show. So we moved it right 2, reflected it, and then from there went up 1, 2, 3 units to land here. Oh, that's a lot of arrows there. Let me take that point at 0, 0. Shift it right 2, so it's here at 2, 0 now. Reflect it over the x-axis. Well, if it's right on top of the x-axis, it's not going to go anywhere. And then from there, shift up 3. 1, 2, 3. And it's going to land here at this position, 2, 3. Right here. Okay, and I'm going to go ahead and connect those dots. So what we've done is taken 2 points on this line and transformed them to these 2 points. So I'm going to draw the new line here. Okay, now I need to take a point on the other side of that V. So let me take this point at 1, 1, shift it right 2, so now it's at 3, 1. Reflect it across the x-axis, so now it's at 3, negative 1. And from there, go up 3. 1, 2, 3. So it's going to land at this position at 3, 2. And now connect those dots. And there's my new absolute value graph. So in blue there is the graph of negative absolute value of x minus 2 plus 3. We took that initial V shape here, shifted the whole thing right 2 units, and then reflected it upside down. So it was this sort of shape, and then from there shifted up 3 to arrive at this blue graph.